Hello everyone, welcome back to Smarter Everyday Over Learning. Dear students, we have been learning the classes from the chapter Organic Chemistry, some basic principles and techniques from grade 11 NCERT. Right, dear students, I have started the subtopic from the same chapter Organic Chemistry, some basic principles and techniques, the qualitative analysis. In this qualitative analysis, the detection of carbon, hydrogen and nitrogen, these three completed, and in the detection of nitrogen, Lassaigne test, the preparation of Lassaigne extraction also completed, and students, about detection of halogens also completed in our previous session. And those who didn't see those previous classes, I'll provide for you the links in the description box. You can go through them. Now students, in this session we are going to learn about detection of sulfur and detection of phosphorus, and the last one is detection of oxygen. Okay, right, let's get into the class. Now let's see detection of sulfur in the qualitative analysis. The presence of sulfur in the organic compound. Presence of sulfur, it can be detected by Lassaigne test. Already you know that about Lassaigne extraction preparation also. Lassaigne. So by using that Lassaigne extraction, we have to do this Lassaigne test. If sulfur is present in the organic compound, then on fusion with sodium metal, with this sodium metal, then students, sodium sulfide will be formed, and to this sodium metal if you add sulfur, that means it's a reverse process. To this sulfur presented organic compound, if you add sodium fusion sodium metal, then on heating Na2S, right, this is sodium sulfide. So by using Lassaigne extraction, let's see now how we can prepare Lassaigne extract by using this sodium metal. Let's see the preparation. Okay students, just by using this Lassaigne extraction, we have to do the experiments to detect some halogens. Now let's see the preparation of Lassaigne extract. This is the organic compound what we have to take for the detection of halogens, right? And students, the most reliable test for detecting that halogens in the presence of organic compound, in this test the elements present in the organic compound are converted from covalent form into the ionic form. And what are the apparatus you need to take for doing this extraction? This is the fusion tube, and these are the equations of sodium metal with halogens and cyanide also. Okay, these are the chemical equations you are seeing on the screen. And now it's a boiling process of a small piece of sodium metal. Here what you have to take, what are the apparatus, and this is the organic compound containing halogens present in that. And what are the materials required to do this activity? Metallic sodium and the distilled water and organic compound, and forceps, test tube stand and forceps, and tongs, funnel, filter paper, wire gauge, and tripod stand, Bunsen burner. Right, now let's see the procedure. First of all, you have to take with the help of forceps a small pinch of sodium metal, that is freshly cut sodium metal, the size of a just like a pea. It is heated gently in a fusion tube with the help of forceps that you have to take in that fusion tube. And this is the tongs. With the help of tongs, you need to place that fusion tube on that Bunsen burner. Then students, what will happen? It is gently heated. Then take a small pinch of that nearly 50 to 60 milligrams of organic compound is added to that fusion tube and heated strongly till it becomes red hot, just 2 to 3 minutes. Then the hot tube then plunged into a china dish containing 10 to 15 ml of distilled water. Then the contents of this china dish are boiled for few minutes, then after that cooled and then filtered. Okay, you are seeing on the screen. Then this is the cooling process. Then now we have to filter the complete solution into a beaker. Okay, now you have to get the Lassaigne extract. Now what are the precautions? Always use forceps while handling the sodium metal because it is highly reactive. And before using sodium, press within the folds of the filter paper to dry it. And use dry fusion tube for sodium fusion. And repeat this process of sodium fusion with 2 or 3 ignition tubes. Ensure the fusion has taken place. And okay students, this is about the preparation of Lassaigne extract. Now by using this Lassaigne extract, how we can test the detection of sulfur? Let's see now. The first one is here, sodium nitroprusside test. So the name of the test is sodium nitroprusside, and to this extraction, already we have done the preparation of Lassaigne extraction. Then students, to this extract, to this filtrate, if you add sodium nitroprusside solution, a small portion of Lassaigne filtrate if you take, then it is treated with few drops of sodium nitroprusside solution. When a violet coloration is obtained, violet coloration, then this color slowly fades on standing. Okay, then if you observe the violet coloration by the treatment of these two, let's see the chemical equation here. For suppose Na2S plus sodium nitroprusside, the formula will be Na2 Fe CN5 NO. Then the violet colored compound, the formula should be Na4 Fe, again CN5 NO, yes, NO, yes. So this is the violet colored compound. When these two are reacting with each other, sodium sulfide and with sodium prusside. Okay, right. This is about sodium nitroprusside test to detect sulfur ions. If the organic compound contains sulfur ions, in that the presence of sulfur, also you can do this test. Let's see now. Second test should be lead acetate. In this second test, lead acetate test. Okay, in this test also we can use Lassaigne extract. What we have done, another portion of the Lassaigne filtrate is acidified with dilute acetic acid, CH3COOH, nothing but acetic acid. And students, if you add to this, you should add lead acetate, few drops of lead acetate solution, and these two are mixing. When the reaction takes place in between these two, Lassaigne extract with dilute acetic acid with lead acetate, then you should get black colored precipitate. Okay, black colored precipitate. This indicates this black colored precipitate is known as lead sulfide. So this shows that the presence of sulfur in the given compound. Okay, let's see the chemical equation for this. To this Lassaigne extract, as I told you, Lassaigne extract nothing but Na2S. And if you dilute this with CH3COOH, acetic acid, and if you add lead acetate formula CH3COO twice Pb, then black colored PbS, lead sulfide will be formed. And students, including with this, along with this, 2CH3COO Na, this is sodium acetate. CH3COO Na, sodium acetate will be formed along with lead sulfide. Okay, this indicates that in that particular organic compound the presence of sulfur. Right, now the next test is oxidation test. The detection of sulfur, we did that. First one is Lassaigne test. In this with this Lassaigne extraction we have done that sodium nitroprusside test and lead acetate test. Okay, these two we have done. And students, now second type is oxidation test. In this, the given compound is fused with a mixture of potassium nitrate KNO3 and sodium carbonate, nothing but Na2CO3. So here these two reactants we have to use, and sodium carbonate Na2CO3. If sulfur is present, it gets oxidized to sulfate. Now let's see the chemical equations for this. If you take potassium nitrate, and it can be decomposed into KNO2 plus O, and if you take Na2CO3 sodium carbonate, to this if you add the chemical compound, that if you add the organic compound which is containing that sulfur and 3 oxygens, then finally sodium sulfate Na2SO4 plus CO2. So this is the balanced equation here, right? 2Na 2Na, 1 carbon, and oxygens here, right? And this is balanced. Now the fused mass is then extracted with water and filtered. The filtrate is acidified with dilute hydrochloric acid. The filtrate is treated with dilute hydrochloric acid and treated with again barium chloride, BaCl2, barium chloride solution. When a white precipitate insoluble in acid is obtained, let's see the equation for this. To this filtrate Na2SO4, here is the formed filtrate. To this, if you add barium chloride, BaCl2, then NaCl, sodium chloride salt will be formed, including with barium sulfate. Here barium sulfate is in white colored, so this is known as white colored precipitate, white PPT. Okay students, right, this is about the detection of sulfur. Here a test with Lassaigne extraction. In this Lassaigne extraction, sodium nitroprusside test, lead acetate test, and the second one is oxidation test. Here oxidation test, if the sulfur is presented in that particular organic compound, that can be oxidized into sulfate ions. So here we have done, these are all examples. Now let's see the next one, the detection of phosphorus. In this detection, we have to use this phosphorus can be detected by fusing the organic compound with an oxidizing agent. Here sodium peroxide. You know students, hydrogen peroxide chemical formula, you know that H2O2, right? And in such a way, sodium peroxide also Na2O2. Okay, simple. So this can be acting as an oxidizing agent when phosphorus is oxidized to sodium phosphate. Right. Now let's see the chemical equation for this. If you take Na2O2 sodium peroxide oxidizing agent, to this if you add the organic compound which is containing phosphorus, then while heating Na3PO4 sodium phosphate Na2O, and while balancing the chemical equation, here 5, here 2, here also 2, here also 2. Okay, this is from the organic compound. The fused mass is extracted with water. The aqueous solution is boiled with concentrated HNO3. Now students, this is the aqueous solution. Sodium phosphate, aqueous solution. Now this aqueous solution should be treated with concentrated HNO3. This Na3PO4 plus H3PO4 and sodium nitrate. Here Na3PO4 is sodium phosphate. This is also called as phosphor soda, and it can be treated with concentrated HNO3 here. Then phosphoric acid H3PO4 is the phosphoric acid, including with NaNO3 sodium nitrate. These two can be formed as products. Okay, now students, this phosphoric acid H3PO4, this can be treated again. H3PO4, this can be treated with ammonium molybdate. The formula should be NH4 twice MoO4. This is ammonium molybdate. To this ammonium molybdate, if you add again HNO3 nitric acid, then this combination, if you heat gently, okay, then students, what you should get? NH4 thrice PO4, 12 molecules of O3 plus NH4 NO3 ammonium nitrate along with water. These are the products. Now we can balance this, okay students, and see the appearance of yellow colored precipitate or coloration due to the formation of ammonium phosphomolybdate. This is yellow colored PPT. The name of this compound is ammonium phosphomolybdate. This indicates the presence of phosphorus in that particular organic compound. This is the entire equation. Now let's see clearly while balancing this chemical equation. Now in the product side, here ammonium phosphomolybdate, here 12 molybdate ions. So if you place here 12, okay, now here NH4 ions, 12 to 24. Then students, if you place directly here 21, NH4. Now here also 3 4 12, right? And if you place here 12, here 21 means here also if you place 21. Now let's count all the elements. This is the net reaction of the formation of ammonium phosphomolybdate here, that is yellow colored precipitate. Right, now let's see the detection of oxygen here. Detection of oxygen. Exactly, there is no direct tests available for the detection of this oxygen in an organic compound. However, its presence can be detected indirectly by the compound is tested for the presence of oxygen containing the functional groups such as alcoholic group and aldehyde group and carboxylic acid group and nitro group. Okay, and the presence of any one of these groups in the compound in turn confirms the presence of oxygen. You can see here oxygens are presented. So number 2, if the sum of the percentages of various elements present in the given compound, as determined by known methods comes out be less than 100. Now the presence of oxygen is indicated and the difference is taken to be equal to the percentage of the oxygen is given to the compound. Okay, just you can ignore this simply, and if you identify this type of functional groups in that particular organic compound, you can say that presence of oxygen. Okay students, right, this is about our today's session, detection of sulfur and phosphorus. In this detection of sulfur, again we discussed about Lassaigne extraction preparation. and detection of phosphorus also. Here with the help of sodium peroxide oxidizing agent we have done all these experiments, and detection of oxygen just by observing the functional groups we have discussed. And now students, this is about the qualitative analysis. In our next session I'll be teaching to you the quantitative analysis in our next class. Okay students, thank you so much. And if you understand this class, if you like this class, please subscribe and click the bell icon for my further updates. Thanks for watching.